Hey, what's going on? So, welcome to my lab for recording. So, this is the lab about we're doing lighting, introduction to lighting, basically messing around with the diffuse intensity, and then also doing what do we call it? Doing specular intensity. So, um, a few things that I have just sort of off the start. Most of this stuff is going to be about optimization. Most of the content stuff is pretty clear, and you should be able to figure out yourself, I think. But anyway, so we're gonna go over everything here, and if you have any questions, feel free to ask me and let me know, and I'll be happy to answer them. Awesome. So let's get into it. So some first things first, just these global variables for global intensity and global color, um, and then also for max light. So that's for the number of lights there that we're going to be able to access during the scene or create. So I've got a length squared function, just doing the dot product to give me the length in squared instead of using the length function, which has to use the square root function. So then we also have square value just for a simple squaring one value. And then also a power of 2 function to eliminate the use of the pow function. So as point, as offset, you know about that, structs, p light. And then init light, just doing the center as a point, standard stuff here. So we had to calculate color. So calculate color, I have a sphere and then I have 2 lights. One light is static and then the other is moving. So using sine and I time, and then it's actually like the where it starts is actually like right in front of the sphere, which is -300. And then I'm adding the cos to making it basically move around the sphere, which is giving it this lighting effect. All right, moving into this. So first, you just have the rendering of the sphere using with some optimizations so that we don't have to use the normalize function. Basically, just here we have using the radius as a way to figure out the normal, instead of using normalize, which uses the square root function. So for diffuse color and specular color, I define them here, but they could also be defined probably in the lighting struct. I would assume, and that would make it so you could have custom like diffuse colors, custom specular color for a specific light. Something I was thinking about. Which it might be what you're supposed to do, but I was just following the instructions and felt like this just made the most sense for now. Also, we have final color. Okay, so going into here now, this is for the lighting and having multiple lights. So we calculate the diffuse intensity first off here, which is more so if I get rid of these. So it's this block here, and basically you've got the light vector. So just from the center of the light, or from this position on the sphere to the center of the lighting object. So that's your light vector, and then you've got. I did some optimizations here, basically to limit the pretty much to get rid of the square root call, and it also works nicely with my attenuation function. By using the squared length of the light vector, I'm able to just use that instead of just having the normal length and then having to square that and use that elsewhere. So it just made sense for me to use the squared length. For the normalized light, so we do the light vector times the inverted square root, slightly more efficient than calling the normal square root function, which would mean you would have to divide So we get rid of a division by doing this. So diffuse intensity. So with diffuse intensity, we're pretty much just using that diffuse coefficient and plus that attenuation function. Did it all in one line just because it felt like it was right. Even though like above you can see I was doing diffuse coefficient and attenuation like that. Anyway, I'm sort of lingering on a little bit. Most of the stuff you can probably figure out. Onto the Blinn-Phong reflectance optimization. So pretty much all I did is when calculating the normal, I'm using the inverse square root. So there's not like a whole lot complicated there. Nothing crazy I felt like. And then I'm also using that power of 2 function for the speculator intensity. Or these, it's, yeah, for just the normal, what is it? It's like K in the Blinn-Phong optimization formula. And then final color, I do the final color adding up for the lights, and then I modify by global intensity and global color at the end, and then return sum of colors. And that's pretty much it. And like I said, if you have any questions, ask me. I'd be happy to answer them. And yeah, awesome. I'm having a lot of fun with this. So and I'm enjoying this a lot, and I'm really excited for the class. So thanks, and I'll see you soon. Peace.